So we're going to go with Chapter 5 review. Let's see. Number 1, classify this triangle by its angles. And of course, we've got to, can't look at it algebraically. We've got to figure out what they are. The interior angles of a triangle, they have to add to 180. So we'll take all these expressions and add them and set it equal to 180. Okay, combine like terms. So we get 6x, and that looks like plus 18. Okay, subtract 18 from both sides, and we get 6x equals 162. X would equal, let's go 27. Right. Now we have to plug back in. So let's go with x plus 40. Sub in and get 67 degrees here. So then 2x minus 5. So we're going to take 2 times 27 plus, oops, sorry, minus 5. That's going to be 49. And 3x minus 17. What's that? 81 minus 17 is 81 minus 17. We get 64. Okay, so then we'll just make sure those add up to 180. Throw those in a calculator, and yes, they do. So that's good. Now, it wants only the name from the angles. So when we do that, we look at the largest one. The largest, now it doesn't look like the largest angle, but it is based on the numbers. So since the largest angle is acute, the triangle is acute. Now I'll add more to it. It's based on the side relationships. None of the angles are the same, so none of the sides are the same. So it'd also be scalene, but they really just want it by its angles. Okay, next one, AD is congruent to DC. All right, so that makes this triangle isosceles. Okay, so ADC is going to be one isosceles triangle. ABD is another one. So I like to, when there's, overlapping triangles or two triangles, I tend to think it's easier to separate them. Now, the measure of angle B is 25 degrees. Using base angles theorem, that means on this triangle only, it doesn't apply to both triangles. So on this triangle only, this is also 25. Okay. So add those together. And technically, just by adding these two together, this is an exterior angle of that triangle. So that's automatically 50. You don't have to do it that way. You could do the 180 minus 50 to get 130 here. Of course, then you're going to go 180 minus 130 to get back to 50 anyway. Okay, that's probably how most of us will do that, which is fine. Now I'm going to go 180 minus 50, and what I have is 130 between these two, but I know they're equal because of base angles theorem. So 130 divided by 2 is 65. So these are both 65s. So that's a measure of angle C. Okay, so continue on, and we have, is there a triangle? Okay, I guess we just got to create one. So in triangle ABC, okay, I'm going to draw a random triangle here and hope that it's going to work out. Angle bisector is drawn, so let's say we cut the middle of this angle. Those are the same, BD, all right? And the measure of angle ABC is 62. All right, so I'll draw that again without the angle bisector. So this whole angle is 62. And they want me to find CDB. Wait a minute. Oh, I missed one. Sorry, BAC is 65. Okay. All right. CDB. So we want that one. All right. So what I would do first is I would take the 62 divided by 2 to get 31. Okay, so there's 31 here and here. Now, I would get this whole angle and then come back to here. All right, I'm thinking that's, actually, no, I don't need to. Yeah, I don't need to. All right, let's scratch that. All right, I have a better way. But, of course, you could do that. I'm going to go with just this top triangle. Okay, so I'm going to focus just in on this one. I got a 31 here, a 65 there, and really I want this exterior angle. Yeah, so I want this exterior angle. I could just add these two. So 65 plus 31 is 96, and that's what that's going to work out to be. I can go about another way. I could subtract from 180 to get this angle. That'd be 84. Of course, then I'm going to go 180 minus 84 using linear pair to get 96 anyway. So, a couple methods. There were other ones that would work too. All right, in triangle DOG, it's isosceles. Vertex G. All right, so let's draw it this way. When they say the vertex angle is at G, that means these are the two sides, and then the vertex angle is this one of the isosceles triangle. These are the base angles down here, okay, because this is your base. This one, the base is maybe not the same as the other two legs. Okay, we learned this in class. In an isosceles triangle, the congruent sides, we're going to call them legs. Then the side that might not be congruent is the base. And these are the base angles because of it. Okay, vertex angle is across from the base. Let's see. And the exterior angle at G. Okay, so they're trying to mess with us a little bit here, which is normal. We know they're gonna try to make it tricky. So there's G. They're giving us 120 on the outside. So I'd go 180 minus 120 to get the linear pair, or the one right next to it, the vertex angle. And then these two are the same. Now you can anticipate these are both going to be 60, but let's go through the process. There's 120 left for these two. They're equal. So 120 divided by 2 is 60 each. So the measure of each base angle, 60 degrees. All right. Last one for the first video. Measure of an exterior angle to the base of an isosceles triangle. Okay, we want this angle right here. And they're telling us the vertex angle is 43 degrees. Now we're going to get a decimal, but let's not let that stop us. 180 minus 43, whoops, because these two are going to be the same. So I'm going to subtract from 180 to get 137, and I'm going to take that and divide by 2, and you're looking at about 68 and a half, I think. So this one's 68 and a half, and so is this one. Of course, you could just add these two to get that, or I would probably go 180 minus 68 and a half. Whoops. That's going to look like 115, or yeah, 111.5. So that one's 111.5. Okay, so that's it for the first video. We'll get to the other solutions after.